before we carry on with our event, just want to highlight the team. As I mentioned, it's a collaboration between the cloud and the data science track. Also working with our evangelist, Nydia Medina, who helps a lot with our social media. And of course, Lindsey, who's collaborating with me today. And then I'm going to pass it on now to Sricheta, who is today's speaker.
Thank you so much, Hope. Let me share my screen. Hey, am I audible?
Yes, loud and clear.
Okay, great. So hi everyone, my name is Sricheta and I'm working with Azure Data with Microsoft for around 3.5 years. But I have an overall experience of 8 years both in India and USA. I have worked with like distributed systems and cloud UI and also backend services, data processing pipelines, infrastructures. I have a 1-year-old son, and currently I'm learning to embrace the balance between the work and motherhood. When I get free time, I love to spend time with my family, and also I like to paint and draw. I like to play with watercolors. So that's about me. Um, we'll start with the agenda. So today's agenda is we'll talk about briefly about Apache Spark in a very simple language, and then we are going to go to the history of Spark, how it started, going to differentiate between MapReduce and Spark, and then we are going to understand the basic architecture of Synapse Spark and also understand a simple flow, what happens behind the scenes when you write a simple Spark Scala statement. And then we'll see one of the cool features of Azure Synapse Analytics, which is intelligent cache, followed by a demo. So that is going to be the agenda of the next 20 to 30 minutes. Yes, so let's get started. So what is Apache Spark? Apache Spark is a open source distributed processing system, which is used for big data workloads. It is used by application developers, data engineers, and scientists to incorporate Spark into their applications, and which they can rapidly query, analyze, and transform data at scale. Tasks which are mostly associated with Spark include ETL, which is extract, transform, load, and SQL batch jobs across large data sets that processes streaming data from a variety of data sets like data from sensors, IoT, or financial systems. And it also helps in machine learning tasks and doing the interactive queries in SQL editor. So Spark isn't just for Scala or Python programmer. It is also for SQL guys. So going back to the history of Apache Spark, so it has really transformed the way we process data, right? So let's take a moment and capture two types of data processing, which is sequential and concurrent. When we talk about sequential data processing, we are looking at tasks one after the another in a specific order. This is extremely slow and inefficient, especially when we are dealing with tons of data. Why? Because we have to wait for the previous task to finish and then start the next one. On the flip side, in concurrent data processing, it is about executing multiple tasks at the same time, which can speed things quite a bit. And this is the approach which is used in Apache Spark in big data processing, where we actually break a very big data set into chunks, which is called partitions, and then process them at the same time. This opens up a lot of possibilities, and it makes it very important for two roles, which is data engineer and data scientists. So when we talk about Apache Spark, we always think about these two roles. For data engineers, Spark is the go-to tool for ETL, for processing massive amount of data, which can be structured and unstructured. When we talk about structured data, we can think about like objects and the lists, vector, and map. You can clean, transform, aggregate, and enrich your data to make it ready for further analysis. So imagine you're working in a real time with IoT devices, social media feeds, and weblogs. A data engineer can use Spark streaming for that. That lets you analyze the data in real time. How cool is that? And then the data engineer can also build pipelines, integrate data from all sorts of sources like database, APIs, flat files, uh, uh, streaming sources, and make sure the data is consistent and correct. Do some data processing from one stage to another. Whereas for the other role, which is the data scientist, Spark has a built-in library called mlib, which provides scalable machine learning algorithms for classification, regression, clustering, and recommendation. Example, NLP. You can use Spark to tackle tasks like sentiment analysis, topic modeling, or name entity recognition. Predictive analysis as well. Spark can help you create and deploy predictive models for things like forecast sales and detecting fraud. Analyze Data scientists can analyze and process large volumes of data and telemetry from the server, from user activities to just identify patterns and diagnose issue. So these are the use cases where a data engineer or the data scientist can use Spark. Any questions so far?
So far, so good.
Okay, great. Going to the next slide. So let's talk about the architecture of Synapse Spark. So this part might be a bit challenging, but I'm going to use simple terms. So let me break down the main components. Starting from the left side, uh, you see a Spark cluster is made of nodes, which you can think of like computers connected together. They work as a team to process loads of data really, really fast. In a cluster, there is a master node, which is like the boss, and there are a bunch of other worker nodes, which do the real work. The master node has something called the driver program, which is the yellow rectangle box, which is going to drive your application. When I say application, it means a Scala, Python, or SQL code. Inside the driver program, we have something called Spark context. Think about it as a gateway to do all the cool stuff the Spark can do. Anything you do with Spark goes through the Spark context. So Spark context works with the cluster manager. A cluster manager, example of a cluster manager can be Yarn or Mesos. So Spark context works with the cluster manager to manage jobs. And when Spark context gets the job, it breaks it down into smaller tasks and sends it to the worker nodes. And each worker node has one or more executors that run the task. Executor is a term that is running in a Java thread, which is the JVM thread. And there can be multiple executors on one worker node, and each executor can run one or multiple tasks, which makes Spark super fast. So Spark, whenever we ask Spark to read a data set, it splits the data set into smaller pieces called partitions, and each partition has a chunk of data which can be processed independently and parallelly across all the nodes. And going to the next slide, where what happens behind the scenes. So, for example, you have a command. Uh, uh, you are trying to read spark.read.csv and then a file name, and then you do a filtering operation on that. Filter on say where column is equal to ABC, and then do a count on that. So when you write that code, what happens behind the scenes? Um, when an action is called, action is like the count method. When the action is called, that is the place, the time where the things actually kick off. So the Spark driver program analyzes the dependencies between the transformation, and it creates something called execution plan. And then it divides the plan into stages. There are further splits each job into multiple stages, and the stages are split based on the dependencies between these mentioned transformations. And there are two categories of dependencies: the wide dependencies and the narrow dependencies. Wide dependencies is something like a group by key, and narrow is something like map. So the difference is between them is dependencies is costly. It involves data shuffling across the worker nodes and between the partitions. It works on multiple stages, whereas narrow dependency works on the same stage. And then the last pillar is the task, which is the smallest unit of the Spark execution plan. Driver program generates tasks for each stage, and a task works on a single partition of data. These tasks are sent to the executors, which process them at the same time concurrently. And when they finish doing the processing, the executors in the JVM threads, they return back with the results to the driver program, and they are saved to the external storage depending on what action is specified in the Spark code. So tasks, they happen concurrently, stages happen sequentially. So this is what happens behind the scenes whenever we try to write any statement in Spark notebook or Spark shell, right? Um, any questions?
We also have a Q&A box if anyone's shy and wants to use that instead. We can take some Q&As at the end if you'd like.
Okay. So I'll move on to the next slide. So the Synapse Spark is different from the open source Spark. Spark is a managed, Synapse Spark is a managed service by Microsoft Azure, and it is fully integrated with other Azure services like Power BI and machine learning and Azure Blob Storage. It has built-in security compliances and management features. Uh, and whereas open source is open source Spark is open source code. It is there in the GitHub, and it is deployable to an infrastructure. So it demands more effort and more expertise uh, to create the clusters and also to manage it. And it does not come with any Azure specific features by default. And the code is in GitHub, and there are instructions to set that up. So you can imagine how difficult it is going to be to set a 8-node cluster on your own by seeing the instructions in the GitHub. So that's why platform as a service or software as a service like Azure Synapse Analytics is awesome, and makes it easier for users to use and explore Apache Spark. And of course, like there are some performance differences between Synapse Spark and the open source Spark. The image that you see is a performance measurement of a TPC-DS query. So TPC is a benchmark, and DS is a data set. It is a data set, and it has like 99 queries. You run these queries, and then you measure the performance of open source Spark and the Spark offered by Azure Synapse, and measure the performance. This is the graph which is based on the performance of runtime 3.1. And because of the performance optimizations that has been done on Azure Synapse Spark, like intelligent caching and optimized sort and limit pushdown, performance of Synapse Spark is better than open source. So that means you can do more with your data at a faster and even at a lower cost. So the performance is almost like 13% better than the open source Spark. The other optimizations that has been done in Synapse Spark is auto scaling and cluster optimizations and indexing.
I got a question in a direct message. What can you elaborate further on what kind of performance improvements can users expect when migrating from traditional Spark to Azure Synapse Analytics?
So in terms of performance, you can think like the time taken to start a Spark session. So whenever you write any command in the notebook, how much time it takes to bring that cluster up, and then when you try to read a file and do a write operation and do some transformations, how much time is taken in that process. So so that is what I'm talking about, performance. And how you can increase the performance is by one of the way is by enabling intelligent cache, which I'm going to talk in the next slide. And the other optimizations can be auto scaling. For example, you make a cluster of 3 nodes. One of the nodes, say, dies because some process killed it. This Synapse Spark is automatically going to bring another node up, so that the service is more resilient and more dependable. Uh, if that answers your question, Hope.
Yeah, it's from one of the attendees, but yeah, that I believe that should answer the question. Thank you.
Okay. Going to the next slide. Okay, so now we are going to talk about one of the features of Synapse Spark, which is the data acceleration with intelligent cache. So traditionally, when querying a file or a table from the data lake, Apache Spark in Synapse, it makes a call to the Azure Blob Storage to read the data. And when you know you are going to frequently repeat that query, the process can be redundant, and there can be latency added to the overall processing time. So this is where intelligent cache in Synapse can simplify the process by automatically detecting the change in the underlying file system, and to ensure that you have access to the most recent data. And when the cache reaches its size limit, it automatically releases the least read data to make space for the most recent data. And we attach locally we attach SSDs to these machines to avoid repeatedly going to the blob storage, which have orders of magnitude in IO bandwidth. And we optimize the file enumerations, and the caching solution is implemented mostly in native code, which is careful for memory and IO management. And also, like, the caching is not done the caching is not done for the original data. Most of the time the data is at very least parsed every time it is read. So why repeat this work every time the cache is accessed? So the cache is designed to parse the incoming data in a different format, which is Apache native tungsten format, and uh, it is a format which is storing the data off heap, not on heap, and that is why the data processing is so fast. And the second is location awareness. The data is placed on nodes that need that portion of the file, and then influence Spark scheduling to locate the future tasks on the node that have the data. Um, So this is about the intelligent cache, and I have a demo next to demonstrate what I just talked about. Uh, so let's go and see the demo, and then mm, see what all questions you have. So I'm going to play the demo. I have created two Spark pools, cache and no cache. In this cache Spark pool, it is a cluster of 8 nodes with intelligent cache enabled with 50% capacity. 50% of the SSDs is allocated for intelligent cache processing. For comparison purpose, I have created another Spark pool, which is again a cluster of 8 nodes with intelligent cache disabled, right? So when we go to the Synapse Studio, I have created two notebooks to demonstrate the uh, difference between the performance with intelligent cache enabled and disabled. So when I create a notebook and this attach a notebook to the pool cache, and I'm trying to read a TPCDS file catalog sales, which is of size 284 gigs and has almost 143 billion rows. The total time taken to read that data frame and do a count operation on that, it takes about 8 minutes 26 seconds. So this particular operation has 4 jobs, and then uh, the total time taken is this. I'm trying to do the same operation again, but because I want to know the timing, how intelligent cache helped. Because when this, I'm going to read that again. It is going to read it from the cache and not from the storage account. We see that the total time has dropped to 7 minutes 33 seconds, which has improved the performance by almost like 10%. And I see the total number of rows returned is the same. Now let's check another notebook where intelligent cache is disabled. I'm doing the same thing again, and this time it has taken 9 minutes 41 seconds to read the file. I'm doing that operation again, and it has taken 10 minutes 44 seconds, the total operation. So the performance has not improved. It is almost the same. There is no improvement as performance between the first and the second read. So this clearly demonstrates the beauty of intelligent cache. Uh, and what happens underneath the processing is we cache these files in a different format, which is the Spark native Tungsten format, which makes the reading even more faster. I hope you enjoy the demo, and thank you for watching.
Thanks so much, Sricheta. I believe that's everything, yes?
Yeah, that's all. Thank
Okay.
you. Hope.
Yeah, no worries. I think that between Lindsay and I, we'll have a couple of questions
I have
to
created 2 Spark polls. Sorry.
no worries. Yeah, we'll have a couple of questions just on everything that you covered. And so I'll start off and just, well, generally speaking, I'm curious to know if you're at liberty to share, are there any upcoming features or developments with Azure Synapse Analytics that for Spark that the audience should be aware of or keep an eye out for?
Yeah, sure. There has been a rapid amount of development in Azure Synapse Analytics. Recently, Microsoft unveiled Microsoft Fabric, which is a different platform than Synapse Analytics, but even more better, uh, where you can integrate data engineering with Power BI. So, this is a new app, but you can do the same thing by integrating with other Microsoft 365 apps for it, like Power BI. And then there has also been more work to increase the performance and the compression time of reading and writing Parquet files uh, um, as we speak. And Microsoft is also uh, working on leveraging hardware SKUs to increase the performance even more.
Amazing.
And then the last question is that, of course, I'm assuming that it will integrate well, Azure Synapse Analytics with other Azure services for data ingestion and storage. But do you know anything about the compatibility with other cloud services like AWS or GCP, perhaps?
No, I think Microsoft Azure Synapse Analytics it is compatible with other Azure services, but yeah, not with other providers in the industry.
All right, thank you. I'll
Yeah.
pass it off to Lindsay.
Oh, this is such a wonderful presentation. I had a lot of questions and you so gracefully kind of answered them throughout the whole presentation. You got really detailed and I really appreciate that. So my hugest takeaway from this, from the data science standpoint, is that there's a significant reduction from time to insights, allowing businesses to make faster data-driven decisions leveraging this technology. So in your experience, what's the most common misconception you see about implementing data solutions like this in real world data science projects? Is there a misconception that you've run into that you kind of had to work through for product market fit or in your development?
Um, Misconception, I think people go people try to go to the open source Spark and try to set up their own cluster on their own, um, which is, I think, very time consuming. If people can go to the services, for example, Spark, and really reduce the amount of time you spent on infrastructure, and then you can focus most of your time on your business and doing on the logic to basically. So that is one thing that I think.
Oh, wow, that's such valuable information. Thank you so much for sharing that. Also just wanted to commend you and your team for the work that you've done on this product. And I just want to take a moment to see from your perspective how this product would compare and stand out against other big data platforms or, engines of this nature in the market.
I think with the new product, Microsoft Fabric, it has really stood out from the other products because how it is seamlessly integrated with other Microsoft apps, and also it has a feature of a concurrent notebook sharing, and it has now the latest. It, uh, it is going to unveil the latest Spark runtime, which is 3.4. I think it really stands out from the other cloud providers. Also, seeing the performance improvements made by Microsoft Azure, uh, it it really stands out from the open source Spark.
Awesome. Thank you for sharing that. And then just one other quick question, kind of around best practices, since you kind of enlightened us about setting up a cluster. Do you have any other on top of mind that you could share with people trying to utilize these tools for data science initiatives?
Yeah, I think most of the concern that people have that they write a Spark job and they're like, why is my Spark job so slow? So uh, so people should know about there are tons of actions and transformations. So for example, count, it collects all the data to the driver node, so the load is on the one single node to process everything, so it is going to be slow. So your job is to understand how the data is partitioned and is if there is any skewness in your job. So it's important to understand some techniques like partition, repartitioning, coalesce to fine tune your Spark job.
Oh, excellent. I can really see how these big analytics engines like this nature make all of the different silos of data teams and development teams kind of work more closely together.
Yeah.
So, yeah, I love it. Thank you.
So
Thank you,
Sricheta,
Lindsey.
wondering, is there a way that people can keep in touch with you? Can they reach out to you on LinkedIn, or do you have any other preferred way to be contacted?
Yeah, sure. Feel free to reach out to me on LinkedIn, um, on a message. LinkedIn message is great.
Okay, I'll post it in the chat. But I would say I think that's about it for today. And just a big thank you for taking the time to come in and share your expertise. It's such a gift, and I think it's what makes the Women Who Code community so special. So we really appreciate you taking the time. And yeah, if anyone has any questions, feel free to reach out to Sricheta on LinkedIn, or you can also share them on the Women Who Code Cloud or Women Who Code Data Science Slacks, and we'd be happy to help facilitate getting an answer for you. So thanks, everybody.
Yeah, thank you, Hope, for doing this, and I hope more women leverage these technologies available around us. And yeah, feel free to reach out in Women Who Code. We have a Slack channel and a great community where uh, be comfortable reaching out to people. We are all here to help and uplift each other.